Now for the concepts of linear dependence and independence. So we'll just have a bunch of terms to start off with. First off, a set of vectors, x1, x2, x3, xn, is called linearly independent when there exists a set of scalars, c1, c2, up to cn. So one for each of the vectors, which are not all equal to 0, but that when you multiply them by the vectors and add them up, you do get 0. So it always works if you let c1, c2 through cn equal 0, that then when you multiply and add, you get 0. But if there's some vectors in that set that can sort of cancel each other, we call them linearly dependent. The 0 vector at the end there, I should point out, is actually a vector of all zeros. 0 with a little arrow on top is 0, 0, 0, 0, 0, all the vector. That's what I put on the side here. Now, the opposite is linearly independent. And we say it's linearly independent if there is no such set of scalars. That is, if you multiply all the vectors by the scalars, any scalars that you can pick to get 0, that can only happen when all the scalars are 0. So question, are these three vectors linearly dependent or linearly independent? 1, 2, 3, 4, 0, 7, -2, -4, -6. Well, the answer to that is by solving. Make up the names for the scalars, c1, c2, c3, set it equal to the 0 vector when you've multiplied and added them together. And we know this, it's the same thing as solving a system of equations. The system of equations would be looking at all the x components, y components, and z components. So that would be c1 plus 4c2 minus 2c3. That has to be 0. And it's a homogeneous system of equations. And that's also the same as solving a matrix. So we'll set up the matrix with an augmented 0, 0, 0. And what we're trying to find are these constants, c1, c2, c3, but we could say find the vector c. And that's the same as finding the intersection of 3 homogeneous planes. Note that c equals 0 is definitely a solution to this vector equation or matrix equation as well. You can look and see what that it is. Always a solution to a matrix equation. If you have a matrix A times x equal to 0, you always have at least one solution, x equal to 0. But there could still be one of the other two possibilities, either one solution or infinity solutions. So what it turns out is that linearly dependent is another way of saying that there's infinity solutions to the linear combination equals 0 equation. Whereas linearly independent is just another way of saying that there's one unique solution, which was the 0. So let's finish this one off and solve it. First, we'll just row reduce. So we had 1, 4, -2, 2, 0, -4, and 3, 7, -6. So use that 1 in the first position and get rid of the 2 and the 3 beneath it. But that means I have to subtract twice row 1 from row 2 and 3 times row 1 from row 3. And then I can get a 1 in the middle of the second row by dividing that row by -8, and I'll subtract 4 of it from the first row and add 5 of it to the second row. And at that point, the second row is add 5 of the second row to the third row. At that point, the third row is entirely zeros. And I have pivots in the first and the second column. So that means I know I have a free variable. So already I know there are infinite solutions, but here's how you write them down. So remember, I called the variables c1, c2, and c3 this time. So turning it back into equations, I get c1 minus 2 to c3 equals 0. c2 is equal to 0, and c3 is free. Or you could write it as c1, c2, c3 is equal to the vector C3 times 2, 0, 1. Right, so that's homogeneous. They never have a non-zero constant vector added to their solution. They're always just purely a multiple of vectors possibly added together, a linear combination of vectors with constants. I can get a specific solution by picking any C3. So if I picked C3 is equal to 1, I would just get the 2, 0, 1. And that lets me know, first off, that there are non-zero answers to that problem. So those three vectors are linearly dependent. If you get non-zero answers, they're linearly dependent. And in fact, you get an infinity of answers. And because those are the only choices, exactly 1, in which case it would be independent, only 0 would be the answer. And or infinity, which is what we say when it's linearly dependent.